Next insertion method we are going to see here is inserting the element before the given node. So in the last video we saw inserting the element after the given node, and here we are going to see inserting the element before the given node. So here also same procedure we are going to use as the previous method, that is inserting node after the given node. So there also we will you will check by using the value of the node. Here also we are going to check by the value of the node. So for example, we need to insert the element 10. Okay, so we have to insert the node with the value 10, and it should be inserted before the 4. Okay, so what we have to do, we have to search for this particular node, and what we will do, we will insert the node before the particular node, and we have to change the address part for the both the nodes. So this is the procedure. So we have to search this. So how we will search as the previous method only. Pre-ptr tends to data is not equal to value, with this condition only. So with the while loop condition only, we will check the particular node and we will do the insertion. Okay, so we will see, first we will see the code. So as like a last one, we are using 3 pointer structure variable, that is a new node, ptr and the pre-ptr. Then next we are using 2 variables, that is num and val. So num is, you will see. The next we are getting the value of the num by using the scanf function. So for example, we need to insert the node with the value 10, means the num is 10. The next element, enter the value before which data has to be inserted. So which data, after which we have, before which data we are going to insert. So for example, I am giving val is equal to 4. Then next, by using the malloc function, what we are doing, we are allocating the memory space for the new node. Okay, then so this is the new node. The next what we are doing, we are assigning the value. So that is new node tends to data is equal to num. So what is the num value? It is 10. So we are assigning the value for the node. And next, ptr is equal to start. So this is the start node, and we are assigning this as a ptr node. Okay, then next we are checking the condition while ptr tends to data is not equal to val. Okay, we are checking the condition. So ptr tends to data. So now this is the ptr node. So what is the data? It is 1. 1 is not equal to value. So what is the value? 4. We are checking the condition. 1 is not equal to 4. So this condition is true. This condition is true means what will happen? The while loop will be executed. So now what we are doing, pre-ptr is equal to ptr. So we are making this node as a pre-ptr. Okay, so ptr node as a pre-ptr. Then pre-ptr tends to next. So this is a ptr, right? So the next node as a ptr node. Okay, then again what we have to do, we have to check this condition. Pre-ptr tends to data. So this is a ptr tends to data. So this is a ptr, right? So 7 is not equal to 4. So again this condition is true. So what we have to do, pre-ptr is equal to ptr. Now what will happen, this node become as a pre-ptr and this is a ptr. Then now we are checking ptr tends to data. So what is the value? It is 3. 3 is not equal to 4. So this condition is also true. So what will happen, this will become as a pre-ptr and this is a ptr. Again we are checking the condition, ptr tends to data. So that is 4. 4 is not equal to 4. So now the condition is false. So if the condition is false means what will happen, it will come out of the loop and pre-ptr tends to next. So this is a pre-ptr, right? So pre-ptr tends to next. So it contains address of this new node. It contains address of this new node, and new node tends to data. New node tends to next is equal to ptr. So this is new node tends to next. This is a ptr node. So the value 10. So now we have what we have done. Pre-ptr tends to next is a new node, and next new node tends to next. So what will happen in this particular part, it contains the address of the new node, and here new node contains address of this ptr node. Okay, then we can return the value. Okay, we can return the value, return the start. So now what we have done, we have inserted the node before the given node, and this is the algorithm and the code. So just we will see this. This we will see the comparison. So we are checking availability, the overflow condition. Then we are creating the new node and allocating the memory space. Then after that, what we are doing, new node tends to data is equal to val. So we are assigning the value for the new node. So here also the same statement, new node tends to data is equal to num we are using. Then what we are doing, pre-PTR is equal to start. Pre-PTR is equal to start. Then next we are checking the condition. Here we have assigned this here itself. So without assigning this statement, here also we can able to execute. So we are checking the condition, PTR tends to data is not equal to num or value. Then if this condition is true, means what will happen, it will execute this statement, that is pre-PTR is equal to PTR, then PTR is equal to PTR tends to next. Once this condition becomes false, what it will do, it will go to the step 10, and there what we are doing, we are assigning the address part for the new node, that is pre-PTR tends to next is equal to new node, then new node tends to next is equal to PTR. So these part will be same for the code and the algorithm, so it will be easy for studying. So here what we are doing, with the data value we are finding that particular node, and before that node what we are doing the insertion.